Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the synthesis of disaccharide, trisaccharide and polysaccharide with the help of the following point we have discussed some of the point regarding that disaccharide, trisaccharide and the polysaccharide, how to synthesize these type of the derivatives by using the concept stereoselective synthesis of beta monocytes which will be obtained starting from the mannose. And if you remember, mannose, D-mannose and the D-glucose are epimers of each other. Epimers means what? The connectivity of the carbon atom or carbon skeleton or the framework of that carbon atom is the same, but they differ only at one configuration, at only one carbon atom. So that type of the conformer is known as epimers, and they are the optically active. On the basis of that, we have discussed some of the scheme how to obtain the beta monocyte starting from various starting materials and how it can act as a donor and how these reaction generally follows the SN2 type of the reaction. And as we know that SN2 type reaction has some special characteristic or the feature that also we have considered with the help of some example. We have discussed that one, and now right now we are going to discuss the chemical methods glycosylation with manosyl donor. Whatever starting material, it can act as a donor, and one is a electrophile and nucleophile, one is a donor and one is another should be the acceptor, and then the reaction takes place. The resulting compound formed generally as a monocytes, beta monocytes. Selectively we are getting, and there as we know that when the carbohydrate compound form as a ring, there is a mixture of the compounds are obtained, alpha and beta. But in this particular case we are getting majority, means major formation of the major formation of the compound will be the beta side. Beta means above the plane, and that type of the product generally predominates, and therefore it is generally or specifically heading of these compounds are stereoselective synthesis of beta monocytes. Let's see here, highly reactive donor acceptor combination seem exempt from this rule. Silver silicate act as an promoter in this case. Condensation of the manosyl donor, structure number 13, with N-octanol, as we know that it is a alcohol, afford the beta linked monocyte, structure number 14, in excellent yield even without any acyl any acyl substituent at O4, which is represented in scheme number 5. And let us see here how it is, what are the starting material. The starting material taken is here. Observe the structure carefully. You will see over here the bromide atom which is present at axial position. Look at carbon number 2, the protected benzyl group OBN, and next other atom, they are also present at equatorial position. And as we know that the general rule, the bulkier group prefer to stay at equatorial position. So according to that, these are the group which are present at equatorial position. This is a protected hydroxyl with benzyl group which are represented, which are shown in the diagram, and this structure is a structure number 13. It is the glycosidic bromide. And this glycosidic bromide, when it is treated with the octanol, the structure of octanol will be this one, CS3, CH2, 7 time OH hydroxy group. That is then it will be treated with AZ, silver silicate. Silver silicate act as an promoter in this particular reaction, and for this reaction the solvent used is CH2Cl2 DCM dichloromethane, and this reaction is kept or carrying out at minus 55 degrees centigrade to minus 30 degrees centigrade, and the yield they had obtained near about is 87% yield is obtained if you keep these reaction condition, and the resulting compound, and this alcoholic group over here, it is when the product is formed, it acquires or it stay at equatorial position, and the reaction takes place according to SN2 type of the reaction. And as we know that SN2 type reaction, it is a concerted reaction. 2 indicate as it is a bimolecular reaction, it is a single step reaction, bond making and bond forming takes place simultaneously, nucleophile approaches from the backside, and therefore the resulting compound always obtain in the inversion. And so keep this point in mind, and you will be getting the product, this one. Let's see here. So here OCH2 7 time methyl group CS3, which acquire or which stay or which prefer to stay at equatorial position, and this alcohol attacking here Br at this anomeric carbon atom, and Br get departed over here, and the resulting compound obtained. Other part of the or other functional group or other part of the molecule does not change over here. Remember, these are the significant or prominent point you must remember here, OBN. Let's see here once again. These are the group which are present at equatorial position. All are the bulkier group. As general rule, bulkier group always prefer to stay at equatorial position. Accordingly, we got this product, and the name of this structure is a 14. And this 14 structure is a very it is an excellent reaction, high yielding product we are getting near about as 87. Generally, the product form, the yield or the product more than 70% are generally known as a good reaction. So now here Paulsen is a scientist name. Paulsen activator has been used with success to synthesize a large number of beta monocytes related to N-glycoproteins. And as we know that N-glycoprotein is a essential constituent of all the organisms, and these proteins are made up by generally there are 20 alpha amino acids are present in the nature, and these alpha amino acids are called as fundamental or the basic units of proteins. And during that protein synthesis, how it can be utilized, there is a formation of the peptide bond, how they are involved, then there is a C terminal, N terminal, according to how it can be formed, that we know that we are not going to go detail of that here. Just remember as a N-glycoprotein. N means there is a formation of the bond between nitrogen and that carbon may be here at this particular reaction. N-glycoprotein, glycolipids and other natural products. Among other insoluble promoters proposed for beta monocyte synthesis, Van Bockels, again it is the name of the scientist. Van Bockels porous silver silicate has emerged as a most efficient activator, and this catalyst even promotes beta selective manosylation by donor, which is shown of the structure 15 at O4 of the disaccharide, which is shown by the structure 16 to a 4, the 4,6 branched trisaccharide structure number 17 that correspond to an ASN linked core substituent, which is represented in scheme number 6. Let's see that also here. Before that, let me clean the scheme number 5. See here. Let's take an example over here. See carefully. This is a structure, and here I am showing this bond clearly indicate that there is no fixed side assigned by this group, that is a bromide group over here, Br. And now rest of the groups, they are remain as it is OBN. That OBN at carbon number 2 next to the anomeric carbon atom. Now the bulkier group which is present at axial position, even though there is a 1,3 diaxial type of the possibility of 1,3 diaxial interaction, it will be overcome by the electron donating group or the lone pair which is present on the oxygen atom. They are responsible for this type of the structure. The stability of that structure decided by this one, and other part, other groups which are present or lying at equatorial position. Now look at this carefully once again. O, then Bn stand for benzyl group, which is a protecting group. And in our previous lecture we already learned that there are some common protecting groups which are used in the carbohydrate chemistry, and that's why we are using those common protecting group, because which can be easily removed under mild condition. And if you remember the criteria for good protecting group, why they are called as a good protecting group, because when we are introducing or blocking the group or the installation of the group at the easiest way, and that protecting group must be commercially available and the cheap, then and then you can use it, or you can call it is a good protecting group. And second criteria for it, whenever we require the desired product, there is a essential to protect, to avoid the reaction at another site, to avoid that reaction at another functional group, it requires the protection. It is mandatory, or what we can call it, it is essential. If you do not protect that group, it will interfere the incoming group. We will not get the desired product, and to obtain, to derive or to get the desired product, we must protect the group. And once you protect the group and reactions are carried out under a different condition, like as acidic condition or basic condition, or during that conversion of one functional group into as another, we are using most of the time oxidizing reagent, reducing reagent. So that protecting group must be sustainable at the reaction condition. If it get disturbed, then it will not be a good protecting group. By keeping all these points in in mind, the scientists are generally carrying out these reaction, taking with caring all the reaction condition, the purity or the possibility of that side product. So look at, this is a structure number 15 here, and this 15 structure, that is a glycoside bromide, act as a donor in this case, and now we are adding here is a disaccharide, and the resulting compound obtained will be the trisaccharide. Which disaccharide we are going to use here? See the structure carefully once again. This is a disaccharide structure present over here. Then now observe the structure carefully. Here you will get, this is a disaccharide structure here, OMP. This is one of the group, and at this position NPH TH, which is a protecting group, which is present at equatorial position. Now OB, not OBN, yes, this is a OBN, benzyl group protected, and here we kept the free hydroxyl group, which is whenever we desire the reaction at specific region, we are making that hydroxyl group free to form the glycosidic linkage, means glycosidic bond formation, and that's why at this point specifically we are keeping this hydroxyl group free. See here N, PH, TH, then at this point there will be OAC acetyl group protection. Here once again all are the group protected with acetyl. As we know that this hydroxyl group, for the protection purpose we are introducing this group in presence of NaH. NaH means sodium hydroxide, and reagent used here or reagent employed here is acetic anhydride. It is a very good acetylation reagent, even though primary alcohol or the secondary or tertiary or phenolic hydroxyl group easily get protected by using this reagent. Now see, this is the structure number 16. When we combine structure number 15 and the 16 together in presence of Ag silicate, Ag means silver, silicate act as an promoter here, and CH2Cl2, that is a dichloromethane, DMC is act as an solvent here. The temperature is near about minus 15 degrees centigrade to 25 degrees centigrade. 25 degrees centigrade is nothing but as a room temperature, and the yield which they had got near about 22% only, 22%, which is a very low yield when they had prepared the trisaccharide. If you observe this structure, you will get here is a trisaccharide structure. Now here what is going to happen? This hydroxyl group is going to attack from this side. This reaction once again SN2 type reaction, nucleophile approaches from the back side and the resulting compound, the leaving group, in this particular case, suppose it is at axial position, the incoming group should stay at equatorial position. And as we know that equatorial position, bulkier group prefer to stay at equatorial position, other things remains as it is. So you can draw the structure here as it is. So this structure we can show here. Observe this structure carefully. This and this combined together, the resulting compound obtained will be this one. So here O, then this will be the structure I am showing here. OMP is the one of the group. Now NPH TH, which is a protecting group. Here OBN, they are present at equatorial position. Now keep other part over here. Now look at here once again NPH-TH, here at this position, the group which is lying at equatorial position, here once again acetyl group, here also OAC means acetyl group. Now here this is the O which is present at equatorial position. Now this is also at equatorial position, and we are going to get over here the structure like this. This is a structure which we got over here, this one. Now here OBN we can write OBN, and this structure OAN, then here OBN, and here also as a OAN. So this is, if you observe this structure carefully, what do you see? There are 3 sugar units, and therefore this is a structure number 17, and this structure number 17 is nothing but as a triglycosides, or it is a triglycosides, or what we can call it as a trisaccharides. One can say it is a trisaccharide. Tri means 3 sugar unit present in this, and therefore we can call it as a trisaccharide derivatives. So this is the compound which we got, and this scheme is nothing but as a scheme number 6 over here. And now George is once again scientist name, George silver zeolite. George he utilized the zeolite nothing but as a one white stone generally present, and it can act as an catalyst in this particular reaction. If you see the previous scheme number 6, where we got only as a 22% of the yield, and economically this kind of the low yield is not useful as far as the economic point of view is concerned, and therefore scientists will be trying trying to design the chemical synthesis in a such a way that by changing solvent, by changing reaction condition, by changing different catalysts and optimizing the chemical synthesis so that the yield of that product is increased. So one of the scientists, he succeed in getting the high yield. What he did, he used as an zeolite as a catalyst, and he is also powerful promoter and has been reported in to afford increased yield and beta selectivity over silver silicate. If you compare these zeolite with the previous one, that is a silicate, this one is a more selective. Selective means beta selectivity. Beta mixture form in a more percentage than the alpha, and therefore it will be a good synthesis as compared to the previous one. And other activators including silver imidazole, silver salicylate and thallium zeolite have also been investigated. So these are the general reaction how the different scientists have tried to increase the yield as well as selectivity, beta selectivity preferentially that we have seen. Now we are going to learn, we are going to discuss the sulfonate approach. The same synthesis we are discussing here, but the approach is different in this particular case. The approach should be the sulfonate approach. See here, the sulfonate approach means perspective. Here we are using as a sulfonate approach. How the selectivity as well as how the yield is increased by changing the different approach that we are trying. The leaving group properties of sulfonate group were first exploited in beta monoxide synthesis by Perlin. Again, Perlin is a scientist name. He used as a sulfonate approach. Why he used as a sulfonate approach? Because that sulfonate is a good leaving group as compared to the bromide, and therefore there are the possibility, the logic behind it to increase the simplicity as well as yield of the product. And in the first step of this approach, monofuranose structure number 18 is treated with TF2O to afford the anomeric triflate, that is the structure number 19, and this is converted in situ to the bromide 20, structure number 20 by Bu4NBr. The name of this reagent is tetrabutyl ammonium bromide. Subsequent addition of methanol led to a 2:3 mixture of the methyl alpha and beta monoxide. 2:3. If you consider 100%, 3 means 75%, and 2 means 25%. So that is the meaning of 2:3. That is the mathematical ratio you can consider over here. Without heavy metal promoters, which are shown in the scheme number 7. Now let us see that scheme number 7, that is a sulfonate approach. See here I am showing this is a structure. Observe the structure carefully. What do you see over here in the middle? This is a carbonate group which is act as an protecting of the cis diol at 1,2 position, and now here at anomeric carbon atom there is a hydroxyl group present over there, OH, and now at this position there is this type of the ring present over C, amide to this type of the group you can consider over here. This is the structure number 18. See here, and this structure number 18 will be treated with TF2O and Bu4 NBr, that is a tetrabutyl ammonium bromide sulfur collidine. It is one of the reagent, and these reagents are carrying out the reaction in presence of CH2Cl2 dichloromethane at -70 degrees centigrade. The intermediate will be obtained. That intermediate I am going to show here. The intermediate will be, sorry, here is not the carbon here. Please make the correction, CMe2, and here remains as it is this way. Then O, here also as a O, C, Me2. Then at this position OO, then C, Me2. This is the structure. Now instead of that hydroxy group there will be the there will be a bromide group Br, right? There will be a, not B, there will be a OTF group, and that OTF group at an this will be converted into this structure number 19, and structure number 19 will be converted into as a structure number 20 over here. So here just you remember, here we will get Br, that is bromide over here. Other part remains as it is here, C, Me2, here O, then C, Me2, like this, and this is a structure number 20, and further it is treated with methanol, MeOH, in presence of the temperature is kept near about -70 degree to 25 degrees centigrade. 25 degrees centigrade is nothing but as a room temperature, and the yield which they have got near about is a 50, I think, yes, 52% yield obtained. And what they got over here, this is a structure which they got over here is a O, again O, C, Me2, there here O, Me, or O, Me means methoxy group. Now other part of the compound remains as it is, C Me2, that is the structure number 21, and where the alpha beta mixture will be obtained in the ratio 2:3. So this is a scheme number 7, which is represented over here. And now the Scourge is the scientist name, once again has synthesized O-benzyl protected manosyl brosylate, trosylate, tracylate and triflate derivatives 23 from the corresponding chloride 22. The respective silver sulfonate on exposure to methanol, the sulfonate 23 give a nearly 1:1 mixture of methyl alpha and beta manosides, that is the structure number 24, which is represented in a scheme number 8. Now let's see that scheme number 8. Let's see over here. They have taken as a starting materials once again in the chair form of that furanose side of the sugar molecule, that is a Cl, chlorine is there, and therefore we can call it as a glycoside OBN chloride. And now all other group which are lying at equatorial position, they are protected one with the different protecting group such as benzyl group, and this is a structure number 22, and this structure number 22 will be treated with the reagent like AgOSO2X, that is one of the sulfonate reagent in presence of MECN, that is a methyl cyanide or the methyl nitride. The resulting compound obtained will be this one again. But here remember, these reactions occur according to the SN1 type, because these such kind of the reaction are taking place via intermediate ion pairs. What do you mean by the intimate ion pair? That the detail of that we already learned in our previous classes, such as I think in a TY-B.Sc level, in a maybe in the 3rd semester I think. So OBN other part remains as it is, only changes are going to take place over here. It is SO2X. This is the group. Instead of Cl, the group is displaced or replaced by OSO2X, and this is the structure number 23, and that structure number 23 further treated with the reagent like methanol, MEOH. The next one is a solvent use again, MECN, methyl cyanide or methyl nitride. The yield is very good yield, HEIL. Yield is obtained near about is via ELD is greater than 90%, and therefore this is a very excellent method to get this type of the product. So let us see the product which we have got, that is O-methoxy. This is a glycoside O alkylation type of the compound for, and once it is O alkylation, it shows the non-reducing properties. Now let us see here other group we can keep as it is, OBN, then here is a RO which are present at equatorial position, OBN, then here once again OBN, and now this one. This is the structure number 24, and this structure number 24 is obtained near about is a 1 means equal percent, so 50-50%, so that type of the product is achieved, and this is the scheme number 8. So I think we have seen some of the schemes, how we can obtain is a beta monocyte, generally is a disaccharide, trisaccharide, whether they are the non-reducing sugar or reducing sugar, that type of the property also we have checked over here. So I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.